In the quick start video, we developed a Blazor Server App, BlazorGPT, to interact with OpenAI's GPT 3.5 model. But how does it work? Let's take a closer look. First of all, we created the app as a web application. ChatGPT debuted it as a web application, even though it now has a mobile app version. Creating our first app as a web application gives you a better understanding of how OpenAI API works. And why do I choose the Blazor Server App? Since we can use many dynamic web frameworks. Blazor Server App and Blazor WebAssembly are the state-of-the-art web technologies that Microsoft introduced in recent years. And the best thing is that Blazor is a pure C# web development solution. It could live without JavaScript running at the front end. You can use only C# codes at the front end. At least that's what I love about it. Use C# from the inside out. Okay, how do we make this app interact with the GPT 3.5 model? We can divide this application into three parts. The first part is the front end, the client-side code. The second part is the back end, the server-side code. The third part is the API call to the chat compilation API of OpenAI. The front end is the web page you see on your browser. It's the interface you interact with the GPT model. You input your prompt into this text box. By clicking the X button, the front-end code sends the prompt to the back-end for processing and waiting for feedback stemmed from the back-end. As soon as the front-end gets the feedback from the back-end, it displays the result on the web page. Whenever you converse with the OpenAI GPT model, the whole app performs all these actions to display the result on your web page. All these actions are performed under the async and await multi-threading technique of C#. Why use async and await? Briefly speaking, this technique allows function calls to be performed asynchronously, so that the application, especially the front end, won't be hung during the processing time. If you want to learn more about async and await, feel free to subscribe to my other course, C# Multithreading, for details. Okay, here comes the most important part, the GPT-3 service class. It's a class under the BlazorGPT.services namespace. It's also the class we use to make the API call to the GPT model. In this small app, the backend only makes the API call to interact with the chat compilation API. So when I explain the GPT-3 service class to you, I'm introducing the backend code and how to make the API call at the same time. This might give you the feeling that all the backend does is make API calls. But actually, it's more than that in a real-world app. In a real-world app, you may add extra actions such as verifying a user credential, writing data to a database, storing or retrieving files, and so on, in addition to just making an API call. But for now, we only do API calls at the back end. The GPT-3 service class consists of three parts. Firstly, we declare three private variables. The first variable, _HTTP client, is a read-only HTTP client object, which will be used to make HTTP connections. The second and the third variables are both constant strings. The endpoint defines the exact URL of the OpenAI API that will be accessed. OpenAI has several endpoints for different models. For GPT 3.5 and GPT-4, make sure to set the endpoint as https api.openai.com/v1/chat/completions. The API key is the secret key that OpenAI generated for you. Secondly is the constructor of the GPT-3 service class. The constructor does three things. First, officially create the HTTP client object. The next two lines create two header attributes. The authorization provides the API key defined in the API key variable. The media type is set to application/JSON. A constructor is used to initialize the class it belongs to whenever that class is used. In our case, whenever GPT-3 service is called, the constructor creates an HTTP client object and prepares those two header attributes. Thirdly, the most important part of this program is the string type async task, the getCompletionAsync method. This method does 5 actions. The first action is creating a request object payload with the required attributes that OpenAI API requires. This object requires two attributes. One is the model name. Here we set the model to GPT 3.5 Turbo. Two is the message. But the message object is an object array, which means it can have more than one sub-object. In this example, we have two sub-objects. The first one contains a role called system and the string, "You are a helpful assistant" for the content. The second one is the role of user, and its content is the prompt you type in the text box on the front end. The system role is pretty interesting. It's a kind of role-play instruction you set to GPT model you are connecting to. Here it just said, "You are a helpful assistant." What if we added another line, "Your name is Jason," behind this line? Let's try it. Okay, input "What's your name?" Click Ask. You see, it said my name is Jason. Can you imagine the potential of the system role? With this attribute, you can tailor the GPT model to act as you need. Okay, the next steps. Serialize the prompt, send it to the GPT API using the HTTP client's post-async method, and await its response. This post-async method does several things. First, we use the JSON-convert.serializeObject method of the Newtonsoft.json package to serialize the payload object created above into a string. This string will be sent to the URL defined as the endpoint variable provided in the first parameter of the post-async method. Before the post-async sends this string to that endpoint, it encodes it into a UTF-8 formatted JSON string. After we get the result back from the endpoint, read the responded object as a string and write the content into a variable named responseBody. The final two steps are to deserialize the JSON object from the responseBody string to the variable result. Remember, I told you since we don't have a clear declaration of the object structure of the content OpenAI sends back, we set the deserialized object type to dynamic, which is not a good way to solve this issue. So later in this section, I'll show you how to create a class object to match the response object that OpenAI sends back. Okay, the last line of this method is to return the information we need to the caller. The information we need is inside the first item of the choices object. So we're looking for index 0 of the choices object. Then find the message object inside choice 0 and extract the string from the field content. Then return that string to the caller. To get the getCompletionAsync method to be seen anywhere instead of BlazorGPT, we need to set the GPT-3 service class as a singleton service in the program.cs file. In the quick start video, we used the builder.services.add_singleton to register the GPT-3 service class as a service. After doing so, we then inject the GPT-3 service into the index.razor page. This move provides the front-end page, index.razor, with the ability to communicate with the OpenAI API. Then how does the index.razor page utilize this ability? The input box binds to the private string variable user input. The onClick event of the X button binds to an async-await method getResponse. Anything you input to the text box is directly bound to user input. By clicking the X button, the program passes the content of user input to the getResponse method. The getResponse method invokes the getCompletionAsync method, which sends the content of user input to OpenAI's endpoint and awaits its feedback. As soon as we get a response from the getCompletionAsync method, getResponse updates the returned value to the index.razor page by updating the response from GPT variable. This is how the whole thing works. Not too complicated, right?